Today, we're going to talk about a piece of tech that's been around for almost 100 years, but is somehow one of the hottest things in amateur radio right now. It's simple, it's powerful, and it might just be the antenna you've been looking for. Let's unpack the end-fed half-wave, the EFHW antenna.
And get this simple little drawing you're looking at, this is it. This is the blueprint. It's from a patent filed way back in 1928, and it's the core idea behind one of the most effective antennas you can put up today. It's not new, it's just been rediscovered. And man, what a journey. So Dr. Josef Fuchs patents it in Austria in 1928. And then, for the most part, crickets. It was kind of forgotten for decades. But then, around 2015, some brilliant folks figured out how to make modern, super efficient transformers, and bam! The EFHW is back and bigger than ever. So what is an end-fed half-wave antenna? Well, at its core, it's just what it sounds like. A piece of wire that's half a wavelength long, fed from the end. But the real secret sauce, the thing that turned it into a modern powerhouse, is that matching transformer. That little box is the key that unlocks its multiband potential. And this right here, this is the payoff. This is why people get so excited about it. You take one simple wire, you hook it up to that transformer, and boom! You have an antenna that works on a whole bunch of bands with a really good match. We're talking a low VSWR, which means your radio is happy, and you often don't even need a separate antenna tuner. It's just simple and effective. Okay, listen up. If you only remember one single thing from this entire explainer, make it this. We're about to hit the golden rule for any antenna, but it is absolutely critical if you want to get the most out of an EFHW.
Let's just let that sit there for a second. It's not about the money you spend. It's not about having some kind of magic wire. The biggest, most profound impact you can have on your signal is getting that antenna up in the air. Height, height, height. It's everything.
But here's the catch, and this is super important. Height isn't just about a number on a tape measure. True antenna height is all relative to the wavelength you're using. So sure, 30 feet might sound high, but to a big, long 80-meter radio wave, you're still playing pretty close to the ground, electrically speaking.
And here it is. Here's the magic number you're aiming for. To really work well, your antenna needs to be at least 0.159 wavelengths away from the ground and any other big objects. Why? Because that's the minimum distance to get out of what's called the reactive near field, which you can basically think of as an invisible bubble around the antenna where your signal can't escape properly.
So, that brings us to the next logical question, right? We know we need height, but why? What's actually happening? Well, to understand that, we have to talk about the two different zones that exist around any antenna, the near field and the far field. This is the goal. The far field is where it's all happening. It's the region where your radio waves have fully formed, detached from the antenna, and are actually traveling out into the world. That's where communication takes place. And to get there, you have to break free from the near field first.
These pictures show it perfectly. Right up close to the antenna wire, you have that reactive near field. It's like this cloud of energy that's just stuck to the wire, not really going anywhere. By getting your antenna up high and away from stuff, you are physically pulling that wire out of the dead zone, allowing those waves to finally form and launch into the far field.
Okay, that's enough physics. Let's get our hands dirty. You get the why now, so let's talk about the how. How do you actually get this thing installed in your yard for the best possible results?
Really, it just comes down to a few simple planning steps. First, just go outside and look around. What do you have to work with? Any tall trees? A chimney? Also, what should you avoid, like power lines? Second, based on your space, pick a shape, a configuration that gets you the most height. And third, mount that transformer box and get the wire up in the air. Now this is probably what you picture when you think of a wire antenna, right? The classic clothesline setup. Just a straight horizontal wire stretched between two high points. If you've got the space and the trees for it, this is a fantastic, simple, and very effective setup. But hey, what if you don't have two perfectly spaced 100-foot-tall trees? Well, join the club. That's where the inverted L comes in, and it's a lifesaver for smaller lots. You go up as high as you can vertically, then you make a 90-degree turn and run the rest of the wire horizontally. It's a brilliant compromise. And look, the options don't stop there. You can set it up as a sloper, a lazy L, an inverted V, even an inverted U. The real beauty of a simple wire antenna is its flexibility. You can make it fit your space. Just never, ever forget that mantra. Height, height, height. All right, hold on. Before you grab your ladder and start stringing wire, we need to cover two quick but really crucial details. Getting these right will make sure your antenna works great and keeps your gear safe.
Grounding can seem complicated, but for this antenna, there's a pretty simple rule of thumb.
It's all about how high your transformer box is. If it's way up there, like over 20 feet, don't run a long ground wire down from it. That wire can act like another antenna and cause problems. Instead, just ground your coax at the other end, where it enters your house. If the box is mounted low, then yes, go ahead and ground the lug on the box itself. Simple as that.
And a quick word on power. Those popular digital modes like FTA, they are tough on gear. Your radio is transmitting for long periods, which creates a lot of heat in the transformer. So the bottom line is, just pay attention to the power ratings for your specific antenna, especially for digital modes. It's the best way to make sure you don't cook your equipment.
So you've done all the work. You've got it high, you've configured it for your yard, you took care of the details. What's the payoff? What does your signal actually look like when it leaves the wire? Let's visualize it. Check this out. On its main band, 80 meters in this case, you get this big, beautiful cloud of a signal going almost straight up. This is amazing for talking to stations around your region. It's called NVIS, and it's perfect for covering your state and the surrounding ones. But here is where that multi-band magic kicks in. You switch up to 40 meters, a higher frequency, and watch what happens. That single cloud splits into two powerful lobes that are aimed much lower, towards the horizon. Now you're not just talking regionally, you're set up for long-distance, cross-country, or even international contacts. The antenna's pattern changes to do the job you need it to do.
Okay, let's wrap this up with the absolute must-knows. Number 1. The EFHW is an old-school design that's been brought back to life by new tech. Number 2. I'm going to say it one more time. Height, height, height. It's the most important thing. Number 3. The reason for that height is to get the wire out of that reactive near field. And number 4. Be creative. Use the antenna's flexibility to find a setup that gets you the most height in your particular space.
We've gone through the history, the physics, and the real-world setup. So now the only question left is for you. Knowing what you know now, I want you to go look at your yard with fresh eyes. That tall tree, the peak of your roof. Where in your space could you give this awesome comeback kid a home?